Alright, so the setup of mine is starting from here, and we go parts of atoms to bonds to group of bonds to life's main groups of elements to measurements. So I'll just take this one at a time with you. Parts of atoms. We have atom, which is the smallest unit of an element that can't be divided further through chemical means. We have the proton, which is a positively charged subatomic particle. It's inside the nucleus of an atom. We have the neutron, which is a subatomic particle, and it has no electric charge, and it's inside the nucleus of almost all atoms. We have an electron, which is the smallest particle in an atom, and it has a negative charge. We have valence electrons. Those are electrons in the outermost shell of an atom. Then we have elements, which are substances that have an equal amount of protons. So like atoms make up the elements. And it basically means just like the same atomic number. And then atomic weight is the total weight of one atom in an element. And then we have an atomic number, which is how many protons are in the nucleus of an atom and element. And that kind of goes back to the elements like as the same atomic number. And so those are parts of the atoms. Then we go into the next section, which is bonds. So we have polar covalent bonds right here. That's the chemical bond where electrons, they're unequally shared between atoms. Then we have nonpolar covalent bonds. Those are chemical bonds where electrons are equally shared between atoms. Then we have double covalent bond, which atoms share 2 pairs of electrons instead of 1 pair, which is the normal. And then triple, obviously, is atoms sharing 3 pairs of electrons instead of 1 pair. Ionic bonds are chemical bonds that are formed with 2 ions that have different charges, like opposite charges. Hydrophobic interactions, as you can tell, like phobia, phobic, it's saying the relationship between water-repelling molecules and then water. So like the interaction with those. And then electronegativity is the fact that atoms attract shared pair of electrons. So those are our bonds. Then from bonds we go to group of bonds, and I just kind of put examples of some of them here. These descriptions are kind of long, but and I don't know if I'm going to pronounce all these right, but hydroxyl is a group with a hydrogen atom that's covalently bonded to an oxygen atom. Then we have a carbonyl, I think that's how you say it, group with a carbon atom that's double bonded to an oxygen atom. Ketone or ketone is a group with a carbonyl group that's bridging 2 groups of atoms. Then we have an aldehyde, I think I'm saying that right. But anyways, it's basically a class where there's like a carbon atom that shares a double bond with an oxygen atom, and then there's a single bond with a hydrogen atom, and then a single bond with another atom or group of atoms. But I try to make it simple and say that it's a group with this structure, and then a carbonyl center, and then a carbon bonded to hydrogen, and like an R group. Try to keep it simple on this one, but anyways. And then a carboxyl is a group with a carbon double bonded to oxygen, and then single bonded to a hydroxyl group. Then a carboxylic acid is an organic compound that's containing a carboxyl group. An amino is a compound with a carboxyl, an amino group, and a side chain that's hooked to the central carbon atom. And amine is a compound that contains basically 1 or more atoms of nitrogen. And then alcohol is a compound with a hydroxyl group that's bound to carbon atom, to a carbon atom. And the sulfhydryl is a group of a sulfur bounded to a hydrogen atom. And then methyl is a stable group of methane that's containing 1 carbon atom that's bounded to 3 hydrogens. So 1 carbon to 3 hydrogen atoms. And those are our groups of bonds. And then from there we go to life's main group of elements. That's our pink purplish thing. Okay, so we have oxygen, which is a non-metal element that makes up 21% of the atmosphere. Fun fact. Carbon, which is a non-metal element that's found in nature, and it's found in natural as well as man-made element combinations. Then next we have hydrogen, which is a non-metal element that is the lightest and simplest of the elements. We have next nitrogen, which is a non-metal element that makes up 78% of the atmosphere. So if you combine these, that's 99% of the atmosphere with the oxygen and nitrogen. Sulfur, which is a non-metal element that's essential for life, and it's one of the most reactive elements, actually. Then we have sodium, which is an element of the alkali metal group, and it's abundant in nature and it's active chemically. Then we have chloride, which is a monovalent anion, which means negative, made of one atom of chlorine. Then we have phosphorus, which is a non-metal element of the nitrogen family, and it's mainly in like an inorganic phosphate form. And then we have potassium, which is part of the alkali group, and it oxidizes quickly in oxygen. And then we have calcium, which is the most abundant metal. It's part of the alkaline metal group, and it's reactive with oxygen. So that's our life's main group of elements. And then lastly, we have our measurements. Excuse me. So we have the gram, which is the unit of mass. That's 1,000th of a kilogram. We have a liter, which is the unit of volume. It's equal to 1 cubic decimeter. Decimeter. Then we have a meter, which is the SI unit for length. We have milli, which is the unit of length that's equal to 1,000th of a micrometer. We have micro, which is a prefix meaning 1/1,000,000th. We have kilo, which is a prefix meaning a multiple of 1,000. We have centi, which is another SI unit that's meaning 1/100th of something. Then we have cohesion, which is the measurement of how similar molecules stick together, while adhesion is the measurement of how non-similar molecules stick together. So pH is the measurement of the acidity or the alkalinity of a solution. Then we have Dalton, which is the unit of measurement for mass. We have molecular weight, which is the sum of the atomic weights of the atoms in a molecule, kind of like what we talked about with the parts of the atom, the atomic weight and atomic number. And then mole is the SI unit for mass of a substance. It contains 6.023 times 10 to the power of 23 particles, which also brings us nicely into the last one, Avogadro's number, which is the amount of units in 1 mole, which is the 6.023 times 10 to the power of 23. So that is my charts